A production function is a way of showing how much stuff you can make with different amounts of things you need to make it. For example, if you want to bake a cake, you need flour, eggs, sugar, butter, and an oven. The production function tells you how many cakes you can bake with different amounts of these ingredients and tools. In economics, a production function is used to measure how efficient a business or a country is at making goods and services. It shows how much output, the stuff they make, they can produce with different amounts of inputs, the things they need to make it. The main inputs are usually capital and labor. Capital means the machines, buildings, and equipment that help make the output. Labor means the workers who use the capital and their skills to make the output. A production function can be written as a formula like this: Q equals F, K, L, where Q is the output, K is the capital, L is the labor, and F is the function that shows how they are related. For example, Q equals K plus L means that the output is equal to the capital plus the labor. This is a simple production function that assumes that capital and labor can be easily substituted for each other. A production function can change over time because of changes in technology or other factors. Technology means the methods and knowledge that help make the output more efficiently. For example, if you have a better oven or a better recipe for your cake, you can bake more cakes with the same amount of inputs. This means that your production function has shifted up and your PPF has moved outward. You can now produce more output with the same inputs or the same output with fewer inputs. There are two types of production functions, long run and short run. The long run is when all inputs can be changed or adjusted. The short run is when at least one input is fixed or cannot be changed easily. For example, in the short run, you might not be able to buy more ovens or hire more workers to bake more cakes. But in the long run, you can do that. The production function helps economists understand how businesses and countries produce goods and services and how they can improve their efficiency and productivity. It also helps them analyze how different inputs affect the output and how they are paid for their contribution. For example, if labor becomes more productive, because of better skills or technology, it can produce more output with the same amount of capital. This means that labor will earn more income than capital. Some real-life examples of production function in industry are: 1. A factory that produces cars uses machines, workers, and metal as inputs. 1. The production function shows how many cars it can produce with different combinations of these inputs. 1. The factory can use the production function to find the most efficient way of making cars and reducing costs. 2. A farm that grows wheat uses land, seeds, fertilizer, water, and labor as inputs. 2. The production function shows how much wheat it can harvest with different amounts of these inputs. 2. The farm can use the production function to find the best way of using its resources and maximizing its output. 3. A clothing company that makes designer wear uses cloth, sewing machines, and tailors as inputs. 3. The production function shows how many garments it can produce with different amounts of these inputs. 3. The company can use the production function to find the optimal mix of inputs and quality of output. Some unique properties of production function are: 1. Positive marginal product. This means that adding more of an input, such as labor or capital, will increase the output, such as goods or services. 1. For example, if a factory hires more workers, it can produce more cars. 2. Diminishing marginal product. This means that adding more of an input will increase the output, but at a decreasing rate. 2. For example, if a factory hires too many workers, they may start to crowd each other and slow down the production process. 2. The extra output from each additional worker will become smaller and smaller. 3. Returns to scale. This means how the output changes when all the inputs are increased by the same proportion. 3. For example, if a factory doubles its inputs, labor and capital, it may produce more than double, exactly double, or less than double the output. 3. There are three types of returns to scale. Increasing returns to scale. This means that doubling the inputs will more than double the output. For example, if a factory doubles its inputs and produces 2.5 times the output, it has increasing returns to scale. This may happen when there are economies of scale or positive externalities in production. Constant returns to scale. This means that doubling the inputs will exactly double the output. For example, if a factory doubles its inputs and produces 2 times the output, it has constant returns to scale. This may happen when there are no significant economies or diseconomies of scale or externalities in production. Decreasing returns to scale. This means that doubling the inputs will less than double the output. For example, If a factory doubles its inputs and produces 1.5 times the output, it has decreasing returns to scale. This may happen when there are diseconomies of scale or negative externalities in production. Some economists and scientists who have contributed to the production function theory and related concepts are 1. David Ricardo. He was a classical economist who introduced the concept of diminishing returns to a single factor of production, such as land, in his theory of rent. 1. He showed that as more labor and capital are applied to a fixed amount of land, the output will increase at a decreasing rate. 2. Charles Cobb and Paul Douglas. They were an economist and a mathematician who developed the Cobb-Douglas production function, which is a widely used form of production function that assumes a constant elasticity of substitution between capital and labor. 2. They estimated the production function using empirical data from the US manufacturing sector. 3. Robert Solow. He was a Nobel laureate economist who developed the neoclassical growth model, which incorporates the production function into a macroeconomic framework. 3. He showed how economic growth depends on the accumulation of physical and human capital, technological progress, and population growth. 4. Joan Robinson. She was a post-Keynesian economist who criticized the aggregate production function as a fallacy of composition. 4. She argued that there is no meaningful way to measure the aggregate capital stock, and that the marginal productivity theory of distribution is invalid. 5. Piero Sraffa. He was a neo-Ricardian economist who challenged the neoclassical theory of production and distribution. 5. He developed a model of production based on physical quantities of inputs and outputs, rather than prices and marginal products. 5. He showed that the rate of profit depends on the income distribution, rather than the other way around. Some recent research and development related to production function are 1. Production and operations management. Challenges and trends beyond 2020. Production and operations management. Challenges and trends beyond 2020 by MD Srikumar, Meghna Chabra, Shalu Yadav, published in the book Emerging Trends in Business and Management by Springer in 2021. 1. The chapter is available on ResearchGate. 1. This chapter deals with vital shifts expected in manufacturing during 2020 to 50. 1. It discusses the impact of digital transformation, smart factories, robotics, artificial intelligence, additive manufacturing, sustainability, and human factors on production and operations management. 2. Long-term growth. Long-term growth by Romain Duval, David Fercheri, Jonathan Diostri, Saurav Mishra, published in the World Economic Outlook by the International Monetary Fund in October 2021. 2. The chapter is available on the IMF website. 2. This chapter from the IMF World Economic Outlook explores the drivers and challenges of long-term growth in advanced and emerging market economies. 2. It proposes a framework that incorporates two interlinked production functions, one for ideas and one for goods and services. 2. It also analyzes the role of policies and institutions in fostering innovation and productivity growth.